similar environment right now, but you need some variation in there in case situations change. Any of you from California? Yeah? How many of you are going to go home and get a big drink of water, right? It's not going to happen. There's a lot of water loss there. So plants, animals, microbes, everything that's there that will adapt to a significant loss of water. And probably most humans will survive without 25% of the water that they're currently using. But a lot of plants won't, particularly a lot of crops and farmland, which is why Governor Bill, by the way, allows farmers to do whatever they want with water. But if we think about it, this random partitioning of a 23 chromosome cell, that's what you have. You have 22 pairs of chromosomes. Can lead to about 8.5 million different variants. How many people are on the planet right now? Anybody, raise your hand and have a real candy at me. Yes.
7.29 billion.
Perfect. That's how we're doing it now. We're putting up a whole crowd. So we can only have about 1/10 of the diversity that's already on the planet. Here's a better question. How many human beings have ever existed? Think about it. How long have we existed? That's Homo sapiens sapiens. Anthropology majors in the room, raise your hand. I have a single anthropologist. Yeah, you're on an anthropology major, yes? No. How many people have ever existed? 100 billion. How do you come up with that?
Yeah.
You don't get any candy for it. Yeah, unless you're all the way in the back. What's a reasonable number?
10 billion.
10 billion. So you think like just all the people plus another 2 billion. How long have we been around? How long have we been around? Go ahead. What'd you say? 107. So you just added 100 billion people in the right? Figure it out. Think about it for a little bit. Come back on Friday. We'll talk about it. It's an important question. And you just look, don't use your brain a little bit. You know? It's far fewer than you would think. Anyway, the main way that we get genetic variation is not by the random assortment of the mom's chromosome she gave you, your dad's chromosome he gave you. It's really the crossovers that are possible between the homologs when they're linked in a bivalent. And you're going to actually have to learn some vocabulary words. Here they are. I apologize. The form that I put actually up online has 2 spelling mistakes. One in here, it's in the plural of chiasma, which is chiasmata. It's, I believe the A is replaced by an O. If you have the sheets in front of you, just draw a little line. They're easy. But remember, we've got, I used to teach at Ohio State University, so we've got scarlet and gray chromosomes up there. Both red ones are sister chromatids. Both gray ones are sister chromatids. When the 4 chromatids come together, they form 2 pairs of homologs, and the whole thing is called a bivalent. And come up with all the names somebody else did, you just have to memorize them. The centromere region is the region where the microtubules attach in order to pull the sister chromatid and homologs apart during anaphase. Any crossover that happens between non-sister chromatids is called a chiasm. If you have more than one, you have chiasmata. What happens if the red one crosses over with the red one? Nothing. It's an exact copy of the red one. That's why they're the same color. The gray one crosses over with the gray one, you never know. But if the gray one crosses over with the red one, then you have some possibility of seeing an exchange of information. And if you look, oftentimes in cells, there's a real chromosome on the left and a pictorial version of it on the right-hand side, you can see multiple of these chiasma, or what are called chiasmata, forming during the first pairing in meiosis, when all the homologs come together. And these chiasmata ensure that there's an exchange of genetic material between homologs. That way your mom and dad chromosomes get mixed up. It doesn't have to happen. You could pass on the exact chromosome your mom gave to you to your kid. correct segregation of homologs in dealing with things, but that's probably beyond the principles that we want to teach in this class. So really, we get to a slide that says, what are the advantages of sexual reproduction? The real advantage of sexual reproduction is that by going by diploid to haploid and back to diploid, we really get a random partitioning of the chromosomes. That gives us about 8.5 million opportunities in a human cell. Much fewer so in, say, like a Drosophila that only has 4 chromosomes. There's only so many opportunities there. It's 2 to the 4th, or just 16 different possibilities. It's really quite small. You get the recombination during crossovers or chiasmatic formation that really leads to the bulk of it. And of course, those are paired together. So you get a random partitioning of chromosomes that have already swapped bits and pieces back and forth between each other. Why is that advantageous? There's really 3 reasons. And for some reason, I didn't like the third one as number 3. I decided to just put it bold, but there really are 3 good reasons for it. It creates offspring with the greatest diversity possible. This is a quote from your textbook, and again, it's one of those statements that I hate. It allows for the evolution of more complex organisms. No, it doesn't, but that's what your textbook says. It basically says the more times you mix things up, the more variations you get. The more variations you get, the more likely it is that one variant will survive. If that variant has something different than all the others, then you could call that a complexity or a variation, and thus you could evolve greater and greater complexity in different cell types, and eventually move that all the way up to a complete organism in terms of its complexity. The main advantage comes from a question that this young woman asked right up here. Why don't we breed with our siblings? And the main advantage there is that if dad is broken, but mom is okay for a particular enzymatic pathway, simply being diploid is usually quite a good thing to do. Because then you generally have a backup copy, and you generally only need one functional copy of a particular gene in order to survive and be happy. In fact, all of you in the room who are female, you have 2 copies of everything on the X chromosome, and pretty much from birth, your body shut down one of them because it didn't need it, and it turned it into something called a bar body. And it can create some disadvantages if it shut down the wrong one by any chance. So who figured all this crap out? So there was a guy named Gregor Mendel. Everybody thinks of him as this pious little monk who sat around breeding pea plants. If you ever actually read into his history, it was kind of an ass. It really was. But he came up with the basic rules of Punnett squares, and God, we're not going to go into them. If you don't know them, then go back to high school, okay? What was done. And what he basically said